To continue discussing functions, we need to talk about function notation. In function notation, the inputs, those are the members of the domain, this is why I called them inputs and outputs, are values of x substituted into the equation. The outputs, members of the range, are the resulting values of y. And if y is a function of x, it is written as f of x. And many people actually write this as f of x equals y. My f of x values are my y values, or the outputs. And again, you can read this as f of x, f at x, or the value of f at x. Now we'll see why we say the value at x. When we evaluate a function, we are substituting the given value in for every x in our expression and then simplifying. So what f of negative 2 is the output whenever the input is negative 2. So there's my input, and this represents my output. So let's take our function f of x equals x cubed minus x, and I'm going to input negative 2 as my x value, cubed minus x, and to input that in every occurrence of x that I have. Try that again. All right, now we will simplify that. On the right side, the left side does not need any simplification because it represents the output. So negative 2 cubed is minus 8, and then we have plus 2, so that this is minus 6. So f of negative 2 is negative 6, which means the input is negative 2 and the output is negative 6. Let's look at another example. Given that g of x, we have a new name for it, g of x equals x squared plus 3x plus 5, find each of the following. Well, the first, this is telling us we want to know the output when the input is x plus 3. So I'm going to go through this expression, something squared plus 3 times something plus 5. My something is the x plus 3. So x plus 3 squared, that quantity squared, plus 3 times x plus 3 plus 5. Now I'm going to do some simplification. So x plus 3 squared is x plus 3 times x plus 3. So that first expression becomes x squared plus 6x plus 9. For the next, we can distribute this 3. We're going to say plus 3x plus 9, and I'll bring down my plus 5. Combining like terms, we have x squared. Let's see, that would be plus 9x. And we can combine 9, 9, and 5. So that's 18 plus 23. So if our input is x plus 3, then our output is x squared plus 9x plus 23. Second part of that, we will have an input of negative x. So we'll replace our x squared. Okay, so that's going to be quantity squared plus 3 times something plus 5. We'll replace each of those values with negative x. Now, negative x squared means negative x times negative x. So that would be positive x squared. That would be minus 3x plus 5. And that is the output when the input is negative x. Notice that is not the same as the original function. Not the same as the original function. That will come in useful later in the semester. Last example we have. Given that f of x equals 4x squared minus 3, quantity, divided by x squared, find each of the following. Well, I have f of 3, so that means my input is 3. So I'm going to write this as 4 times 3 squared minus 3, divided by 3 squared. Now I'll simplify this. So 3 squared is 9. So that this chunk here is 4 times 9, or 36. 36 minus 3 divided by 3 squared is 9. And that simplified 36 minus 3 would be 33, so 33 over 9. And that, f of 3 equals 33 ninths, means that when my input is 3, my output is 33 over 9. Oh, that reduces, doesn't it? That would be 11 thirds. So when our input is 3, our output is 11 thirds. Now for part B, same process, but we'll replace our x with negative 3. And I make sure that I use parentheses around things when I substitute them in for this very reason. Well, that would actually be 36 minus 3 over 9, which would still be that 11 thirds. That would reduce. So the f of negative 3, if the input's negative 3, my output is 11 thirds as well. Notice those values are actually the same. That will have a special name later in the semester. Now for our last bit of information, we have f of negative x. So this would be 4 times negative x squared minus 3. And again in parentheses, and then negative x squared. That would be 4x squared minus 3 over x squared. Notice that is the same as the original equation that we had. And again, that has a very special name later.